Hi, in this video, we're going to solve a problem which appeared in JEE Main 2019. Let's go ahead and understand the problem. So here we have a linear system of equation where the coefficient of x and y are given in a greatest integer function form. Okay, so now we have to check, right, that in which interval we have infinitely many solution and unique solution, and the intervals are given, so we have to check only in the interval pi by 2 to 2 pi by 3 and pi to 7 pi by 6, and that's the problem. So let's go ahead and solve the problem. So first, we consider the given system of equation. So here we just rewrite the system of equation as it is given in this problem. So it's box of, I just read that greatest integer function as box of something so that it is easy to speak. Okay. So that box of sine theta into x plus box of minus sine theta minus cos theta y equal to 0. And similarly, we get that cot theta box and plus y equal to 0. Now we'll rewrite it in the matrix form. So this given system of equation then can be rewritten as in a matrix form as Ax equal to 0, where the A matrix is the coefficient matrix. So the entries of the A11, the first row, first column will be some box of sine theta. First row, second column will be minus cos theta box thing, and it will be cot theta and obviously 1. Also, we can find out that what is my x. So x is the variable matrix. So here it will be x, and obviously we'll have the y. So that's it. So we obtain that ax equal to 0 matrix. Now, this linear system is a homogeneous system as it is having that, right, ax equal to 0. So it's a called homogeneous system. This homogeneous system has infinitely number of solution if determinant of the matrix is 0. So let's calculate the determinant. So therefore, if we calculate the determinant, that it is a 2 by 2 determinant of A, so which is very simple. So it will sine theta into 1 and minus cos theta box product into cot theta. So therefore, if we remove that 1, we can get a equation. And that's it. Now, this equation, that box of sine theta minus cos theta box and cot theta will be equal to 0, then it will have a infinitely many solution. So what will happen if determinant of A is not equal to 0? In this case, obviously we have a unique solution. So therefore, the condition also we receive for unique solution, right? Because for unique solution means that A inverse exists, and then we can multiply that. And that's it, okay? So that's the unique solution, and that's the problem. So now let's go ahead. Now, we need to find out and check that in the given interval pi by 2 to 2 pi by 3 and pi to 7 pi by 6, right, is that relation whatever we obtain regarding that greatest integer function, is it 0 or non-zero? So let's proceed. So now we can easily obtain that, right? That in this particular case, right, first we consider the interval that theta belongs to pi by 2 to 2 pi by 3. Now observe that pi by 2 to pi by 3 means that it is lies between 90° and pi by 3 it means 60. So 90 to 120 degrees. So it lies in the second quadrant. So theta lies in the second quadrant. So in that, sign is positive and everything else is negative. And also therefore we can say that sine is belongs to sine pi by 2 is 0 and sine 2 pi by 3 is obviously minus root 3 by 2. So therefore sine theta belongs to root 3 by 2 and 1. I speak it as minus root 3 by 2. It should be positive because in the second quadrant, right, sine is positive. Sorry for that. And now observe that, right, that we need to calculate also cos theta. So see that cos theta belongs to minus half to 0 in this particular interval. We are looking to find out that minus of cos theta. That's why minus of cos theta is belongs to 0 to 1 by 2. If we multiply by minus 1, we can get that interval. It is a very simple thing, right? Now we need to find out the grid box of sine theta and minus cos theta in this interval. So therefore we consider the number line, and we consider the typical points whatever we are having in the interval notation. Now notice that sine theta is belongs to root 3 by 2 and 1. Now, what is the box of x or the greatest integer function? It is actually denotes the value or integer value of x less than equal to x. So what is the greatest integer if sine theta is lies between root 3 by 2 and 1, right? So the greatest integer, if it is lies between root 3 by 2 and 1, it's actually 0. So therefore we can find out that in this interval sine theta, the box is actually 0. And what is the cos theta? Cos theta or minus cos theta lies between 0 to half. Here also the greatest integer less than equal to that, it will be 0. So therefore cos theta box is also 0. Now see that as box of sine theta and box of cos theta is equal to 0. So therefore the delta, right, that means the determinant whatever we calculate is equal to 0 in this particular interval. So therefore in this interval we have a infinitely many solution. So that's it. So now we have to test the second interval. Let's go ahead. Now if we go ahead and calculate or consider the second interval, notice that it's pi to 7 pi by 6. That means pi plus pi by 6. That means it will be pi plus 180 degree and pi plus pi by 6. Pi by 6 is 30. So 180 to 210. So therefore it lies between, it's in third quadrant. In the third quadrant, tan, cot are positive and everything else are negative. So therefore, in this case, sine theta will be belongs to 0 to minus half, cos theta belongs to minus 1 and minus root 3 by 2. We can easily calculate that sine pi, sine 7 pi by 6, cos pi, cos 7 pi by 6 in a normal form. So based on that, we can easily go ahead. So therefore, here, if we go ahead and see minus cos theta belongs to root 3 by 2 and 1, right? Now, let's proceed. So if I consider the number line in this particular case and consider these typical points, so therefore we can say that sine theta is lies between 0 to minus 1 to 0 to minus up, right? So it lies between minus up to 0. Okay, that's it. Now if it lies between minus up to 0, right? So then what happened, right? So therefore what will be the largest integer? That is greatest integer less than equal to x, right? It will be minus 1 because theta is lies here or sine theta lies in minus half to 0. So therefore the largest integer is minus 1. So therefore box of sine theta in this case is equal to minus 1. If we calculate the cos theta or minus of cos theta, where cos theta lies is root 3 by 2 and 1. We already seen that obviously 0 is the greatest integer. So therefore, we can calculate that box of cos theta is equal to 0. And hence, right, we can see that as box of cos theta is 0. So therefore, here cot theta, the box is need not to be calculated, right? So we should not calculate that. So therefore, in this case, delta is equal to minus 1, which is definitely not equal to 0. Hence, in this interval, we have unique solution. And that's it. So therefore, we can easily see that the option A for this problem is the correct answer. And that's it. So here, always remember that when the problem comes regarding the box product, box thing, right? The greatest integer function, always draw the number line and guess it. Try to find out the largest integer less than equal to that particular value. It's easy to go ahead. Hope you understood the problem. Thank you.